We're going to look at this problem here today. It's 2021 AMC 10B problem 11. And Grandma has just finished baking a large rectangular pan of brownies. She's planning to make rectangular pieces of equal size and shape, with straight cuts parallel to the sides of the pan. Each cut must be made entirely across the pan. Grandma wants to make the same number of interior pieces as pieces along the perimeter of the pan. What is the greatest possible number of brownies she can produce? And there are 5 options here, A, B, C, D, E. So the first thing we want to do is draw a graph and visualize, because we've just read a really long problem. Well, compared to some other problems, it's really long, and we're kind of confused here. So let's draw the rectangular pan, and each cut must be made entirely across the pan, and the cuts are parallel to the sides of the pan. So let's draw the cuts. Now, the problem we want to solve is what's the greatest number of brownies you can produce? So the number of interior pieces of brownies are equal to the pieces along the perimeter of the pan. So what are the interior pieces? So this part here that doesn't touch the edge of the pan is called interior. It's the part I shaded in blue, and this part here I'm shading in red are the brownies that touch the perimeter. So if we want to use brute force, which is basically trying out every answer and ruling out the options that don't work, it will take a lot of time, because first you have to factor each answer out. Say 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6, etc. And you have to do that for every single number. And the numbers have all have a lot of factors, so it'll take a lot of time. Secondly, you don't know if you are going to make any mistake in the middle of calculation, since it's really long and confusing and boring path to take. So let's try out an algebraic expression. So Let's say the length is m brownies. So the length is m brownies worth of length. And n brownies worth of width. This basically just means it takes up n brownies width to fill up this whole width on the perimeter. It takes up m brownies length to fill up the length of the whole pan. So let's start. We have to represent the 2 parts, blue and red, with m and n. So let's do blue first. It looks way easier, because we can know straight away that we've missed out 2 columns and 2 rows for the blue brownies. So that would give us m minus 2 times n minus 2. So what are the red brownies? The red brownies, may be a bit confusing, since we're not exactly figuring out the perimeter, so it's not 2m plus n. We're figuring out the number of brownies, and the brownies in the corner contribute more to the perimeter, because 2 sides are counted in. But if we think of this simply, the question states that the number of blue brownies and red brownies are the same, and blue plus red is the total number of brownies. So basically, it's the total number of brownies, mn, over 2. Now we have our equation. We'll try to expand it, and then we can try to factorize it again and see what we get. So mn minus 2m minus 2n plus 4 is mn over 2. And we can try multiplying both sides by 2, so we get 2mn minus 4m minus 4n plus 8 equals mn. We move mn to the other side, to the left side of the equation. We get mn minus 4m minus 4n plus 8 is 0. So this looks familiar, and it's called the Simon's favorite factoring trick. So basically what we do is we factor m first, and we get n minus 4 for the first 2 terms. We leave the last 2 terms alone, and now after the first step we try to make negative 4n plus 8 a multiple of n minus 4, so we can factor this into this. So what can we do? Well, clearly we already have a 4n, and we don't want to plus any more variables to the other side, to the right side of the equation. So we can only add constants. So n minus 4 times 4 is going to be 4n minus 16. And if we take the negative of that, since it's negative 4n, we get negative 4n plus 16. So we want a plus 16 here. And currently we have a plus 8, so we should plus 8 to both sides of the equation to get plus 16. Now we can factor this out. This is m minus 4 times n minus 4 equals 8. This is a really easy thing to do now because m and n are integers and 8 is also an integer. So 8 equals 1 times 8 times 2 times equals 2 times 4. There are only two cases. Simple. We just try them out. So the first one, m equals 1 plus 4, which is 5. N equals 8 plus 4, which is 12. Notice it doesn't really matter which is m and which is n because we only want the product of m and n, so the order doesn't matter. So mn is going to be 60. The second case is m equals 2 plus 4 is 6, and also n equals 4 plus 4, which is 8. So that's going to be 6 times 8 is 48. So obviously 60 is larger than 48, and we'll choose that as our answer. So we scroll back up or move back up to the question if you're using the paper, and also we just choose D60 because that's the largest answer we've got. So thank you for watching. Remember to like, subscribe, and share, and also comment below for feedback so I can improve my videos and also my learning progress. Thanks, bye.